Hi, I'm Joe. Today I would like to share a session that's regarding about UNS, Unified Namespace, and Unified Analytic Framework for the blueprint that you would like to achieve to be uh, Industry 4.0 for advanced analytics. So, okay, future of manufacturing we're talking about today is there's a lot of things that is converging from operation technology to information technology. Then you got the components of automations of the robotics arm, securities, smart sensors, cloud computing, AI, machine learnings, and advanced analytics. But all these actually, Industry 4.0 require quite massive extensive of data that need to be really gathered together in order to make the good decision. But I mean, if you are a plant or maybe utilities, or oil and gas that has been built for multiple decades, of course, you're going to be a lot of data silos. I mean, that's pretty much easy to understand. But of course, if you're going to be a new plant to set up tomorrow or in the next 2-3 years, you got the privilege to really move into a very good blueprint to design or to decide what you're going to do in order to achieve Industry 4.0 in the coming few years. So, I mean, before that, when every time we walk into a plant, that data is definitely important. But how do they gather the data, present the data? It sometimes can be quite messy, to just stick every week and passing in between departments for an Excel, for even sometimes a handwritten document and notes from there. Well, that used to be. I mean, I would say until today, perhaps many SME, I mean, that struggling to move into much advanced automations of their factory and the plant, still doing the same thing. Perhaps quite a big amount of them as well. So what is matter? Is because for the past 40 years, there's a lot of, like important data has been very concentrated into two types of stuff. Okay, so they call it descriptive. First, you assign the context about what you want to go to measure, what you're going to be understand from the flow. That's descriptive. And then we talk about diagnostic if something that happens. When something happens, you prompt to go back and look into, what caused the accidents, what caused the food quality or the product quality has been degraded due to certain pattern or something wrong. So that's something that what did happen? But to go into Industry 4.0, you're looking into even something more like predictive in advance, that if you can know that what is going to be happen, your production quantity, things to be maintained, maintenance, things going to be down for your production line. So you got some forehand about what is going on. And because of that, you can predict and to really take action on top of it. And next is going to be even prescriptive. If you talk about, you can have some kind of like, prescriptive, answers to what is going to be happens when the sensors tell you something. So, but this all really massive amount of data that's come from a lot of the sources, and most important, the data integrity must be good, must be cleansed, must be normalized, and also contextual before you use. Because anything that perhaps more than 3%, I would say, from the industrial understanding of the data, non-integrate, not less integrated in integrity on that, it will really affect the result of your predictive. So I mean, from last time when these things are silo, you got operation technology, you got IT. Now today you need to converge and get all the massive amount of data. So you used to develop every time you want to have a data, the vendors become a develop and point to a certain system to get the data. And then when years gone, it looks like something like that, the matrix. So, but in a way, I mean, I would say that, even the new plan, if you do not really have a good architecture and blueprint, you would tend to develop a scenario like this, something that really no interoperability. So the problem cannot be really like using a 3.0 to really mock up something and thought that you're becoming 4.0. That doesn't make sense. It will still will be very much costly to maintain. Can't achieve what you want to do. It's still a pretty much 3.0 challenges. It's difficult to change the workflow and process for most of the matrix siloed plant. Difficult to set up systems, facilities again to change it. And the problem is now you can't even achieve something that you want to do in advanced analytic. So these are the real challenges, ahead. And every time in a plant, you have a level 1, it is down to earth, all the machines, then you got level 2, we have a gateway, PLCs, devices. Level 3, you got historian, scale downs, analytic and reporting. And then to even level 4, how do you actually even has an overview of the manufacturing efficiency of the whole plant? And then that's the time even talk about how you can start to even integrating into ERP, enterprise software, and to provide even a much more advanced and smart and intelligence report for you to better manage the plant. And eventually, these days, if you have multiple plants and points of data, moving it to the cloud, to the data lake, not only save cost, but it can be start to talk about how you securely share all the data in between different plants and make it even much more like the smarts in terms of the output of the reporting. So you got something that if this thing about, if the namespace, for example, if the data can be really understood in between all different level, how nice. So from then you do not have a different protocols from different PLCs like Modbus, OPC, UADA, or maybe a lot of PLCs protocols from different vendors. Straight away, everyone will speak the same language, and everyone listen to each other easily. Unlike to be like, you got English, Mandarin, Japanese, Tamil, Spanish. These are the key problems of the industry for many years. So there's a way that you can decouple the architecture. Think about if you already have something that it can be sit in between that help you to manage all the messages and speaking the same language. How nice that you do not need to really have a extra and specialized cost or efforts to maintain the kind of like data integration like we just see on the matrix. So that's MQTT. I would say the design for this purpose, decouple the clients and the brokers, really publish and subscribe protocol that act like post office. You can put up the letter, people come and require that, or the postman will help you to distribute it. Extensible, very scalable, probably from 50 sensors, 110 sensors of data can go up to millions. Reliable, that you can set, even though you got a very unreliable network, you can still really make sure that you are able to configure in a way how to ensure you that you listen properly until you get the data. So you can even configure up to that way to get reliable, data storage in a very critical environment. So it looks something like that, pops up pattern. Very simple sensor go in, would I want to take the data, can do it. But most important is bi-directional. It can be also bi-directional. You can write back something, and receive something, push something that make very much like client technology, decouple technology. So looking back into the level 1, 2, 3, 4, where we just explain how nice if you have an MQTT that can really bring the signal, speak the same language across the entire plant. And that really create a foundation of at least that people speak, listen to the same data format and make things become faster. Anytime you can buy a sensor from any brand, plug and play. Anytime you can change from SAP to Oracle or Oracle to SAP, plug and play. So things become much advanced, in the future. So this is something it look like, when you have MQTT, you look at it, you can really decouples. So everything going in and go out is no problem at all. But another situation is that, but when you have the namespace, but you still tend to speaking to each other a lot. You speak to the historian, the speak to BI tools, the Excel need to go to the to the ERP. They need to do some notification. MES needs some data, and then it's going to be bi-directional, sending to some advanced analytic software, then putting on the cloud. And that is quite pretty normal when even if you have a unified namespace. But do they talk to each other? Do they actually conform to, can be really published and subscribed from just the namespace itself? Or they actually will still have certain kind of like API middleware requirement to pass data? Can be HTTP if there's not MQTT. And how can you do that, with this kind of like requirements still intact? Or that's why you talk about unified analytics framework. Something that we sit in between. By the end of the day, the architecture and the blueprint is that you have something that you can already get ready for all the connectors, all the protocols ready with APIs, everything's ready to really make sure that everyone come in, they have a space that how can they speak to each other with the same data format, if possible, like MQTT. If it is not, you still can use the framework to really mix, the data to be accessible to multiple sources. So that's a beautiful blueprint, isn't it, in the future? So that's how we can help. If you think that this is something that um, you're currently facing a lot of problems, and how we can really put up a few of our portfolio to really help you to grab data from the ground until you can put raw data, until you can go through this middleware of flow, that even to achieve advanced analytic like predictive, for your plans. So, well, contact us if you require more information. Let me just pull my camera video a bit update, then you can see that what we do. We are very focused and specialized to be really help you to getting data from different sources of protocols, and then to achieve it by using unified namespace, MQTT. Then from there, they can really help you to store all the data, pump into a historian, getting all the raw data ready, compressed, ready, anytime for 5, 10, 20 years without any intervention, until that you can get any things that you require to be write and read, from other data sources via flow, and also using flow to really design some advanced analytic, like predictive, or even prescriptive, and even cleansing some of your data, census data, before make full use of it. So come contact us if you require more information. www.matrixinvent.com. Thank you.